Hello and welcome all of you. Today we will discuss IP subnetting math. So, subnetting, as we all know, is a very confusing topic, and also many people are actually afraid of this topic. So, when we say about subnetting, most of the people say that I am weak at it, I don't understand, and if I have to do any kind of subnetting, I just use the online calculator that is available. So, today I want that calculation easier for all of you. I want to tell you how to do a subnetting math here that will make your life easier, because there are situations when there is no online calculator available or even offline calculator available. So if you are in a situation where you really have to find out what if the IP address is inside a particular subnet range, or you need to find out the subnet ID or the network ID and the broadcast address of a particular IP address that is given to you, this subnetting math is going to make your life a lot easier. As we all know that an IP address, an IPv4 address is a 32-bit address and is usually written in a dotted decimal format. So usually it is written as x dot x dot x dot x, meaning that all of these x are some values and they are divided into four octets with these three decimal points. So all of these octets have 8 bits in them, making them a 32-bit IP address. So as we all know that these IP addresses have been classified into different classes. Okay, so here are those values. So the class A here, just note that this classification is basically done by us humans. It is for us, our understanding. The computer or any networking device is not bothered about these classes. So these classes are for human understanding, and these classes are based on the value on the first octet as mentioned here. Meaning first octet, meaning let's say that I write an IP address like 192.168.40.1. This classification of IP addresses is based on the first octet here. So any value here, if it ranges from 1 to 126, that belongs to class A. Anything that belongs to 128 and 129, between 128 and 129, it is class B. From 192 through 223, it is class C. Class D, if it is 224 through 239, and class E, if it is 240 through 255. So based on these classes, based on these numbers, based on these numbers, we classify these IP addresses into 5 classes, and mostly we use the first three classes, that is class B, and class C. Okay, and you can see here on the bottom of this screen that these classes have different bits assigned to them, right? We will see those bits later in this video. So based on those bits, how many network bits do we have in class A? So we have 8 uh, network bits in class A, and we have 16 network bits in class B, and we have 24 network bits in class C. That is what here it says. So the first, in a class A, the first octet has 8 bits. The second has 16. Sorry, the class B has 16 and class C has 24. Meaning these octets, 8 bits mean 1 octet, 16 bits mean 2 octets, 24 bits means 3 octets, right? So As we all know that an IP address is usually divided into network bits and host bits, right? So we will understand what are these network bits and what are these host bits. As you can see here, let me write down an IP address, for example, that I used earlier, 192.168.40.1. This IP address is a human readable address, right? And once we write an IP address on a command, we also write after this something that is called as the address mask, right? So usually it is written in this dotted decimal format, like 255.255.255.0, right? It is usually written in this format, or it is written in a slash format, like slash 8 slash 16 slash 24, or slash 9 slash 17 slash 25, etc. So all these formats are actually a human readable format, but any programming device like a computer, router, or a switch cannot understand this human readable format. They only understand binary digits, and they are 0 and 1. But understanding binary digits is difficult for us humans, and that is why we've formed a decimal format to it. So now let us understand how the computing devices see these addresses. Now we have seen how we read the IP addresses in human format, but let us see how the computing devices see these addresses. Until unless we understand how these computing devices see these addresses in the binary format, we will not be able to understand how do they do the subnetting. So as we all know that they understand only binary digits, that is either 0 or 1, or a combinations of zeros and ones. That is what any computing device understands. So any computing device understands IP addresses using three rules. Those rules are: first, there should be no interleaving ones and zeros. No interleaving ones and zeros. Meaning that IP addresses in binary format cannot be written like 10101100111000, etc. You cannot write an IP address in such a format. Any computing device will not see this as an IP address. The second rule says that if an IP address has ones in it, all the ones should be on the left hand side, meaning 1 1 1 1 1 1 1 1. All of them should be on the left hand side. The third is that if there are zeros in an IP address, all these zeros should be on the right hand side. Okay, so if we combine these two together, right, this usually this would actually look like this: 11000000. So this is the binary IP address format that any computing device understands. Now, what do these ones mean and what do these zeros mean? These ones means that they are the network part, and zeros mean they are the host part or host bit, network part or network bit. Okay, so let me make it a bit easier for you to understand this, right? So this is how a computing device sees a network bit, and a host bit. So if you see here, as mentioned in this diagram, for class A IP address, right? For class A, we know that the slash number is /8. So /8 meaning that in the first octet, only the first octet is the part of a network. First octet plays as the network octet, and the rest of the octets are the host octets, right? So if you see here, this network octet contains all ones and the other are zeros. So using the three rules, all these network bits, meaning all ones are on the left hand side and all zeros are on the right hand side. Similarly, for class B, which has 16 as its slash number, right? So the first two octets, if you see, all are ones and they all are on the left hand side and zeros are on the right hand side. Similarly, for class C, which is /24, all ones are on the left hand side and all zeros are on the right hand side. So if you see here, all zeros make the host bits in all the classes. So whenever there are ones, the computing device consider those bits or those parts as the network bit or the subnet bit. The rest of uh, the rest of the part of this 32-bit IP address would be zeros. All those zeros would be considered as the host bits. So what happens now is that I would want all of you to remember this table very well. And why is that so? Because this would actually make our subnetting math much easier. Okay, so let me explain this diagram here first, or this table here first. So as we all know that in an octet there are 8 bits, right? So there are 0 0 0 0 4 5 6 7 8 8 bits in an octet. Okay, and as I was saying, when a computing device reads an IP address, all the ones should be on the right hand side, right? So if we take the left side bit as 1, convert it into 1, the value would be 128. How? If we convert, right? If we convert a binary number to a decimal format, we convert it using a base 2 format, right? So the this last bit would be 0th bit. This last bit would be the 0th bit. The next is 1, 2, second bit, third bit, fourth bit, fifth bit, sixth bit, and the seventh bit. So when we are converting a binary digit to a decimal point, we convert them using a base 2 format. So the last digit will be written as 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 5, 6, and 7. Right now, if we convert this last digit to 1 and keep others as 0, 5, 6, 7, 8, the last digit's value is 2 power 7, right? And 2 power 7 makes it to 128, and this value is written as /1. If you see here, you can consider this as /1. And as we start to add consecutive ones from left to right, all these bits are set to 1 as given here, and these values start to add up, right? So it is 2 power 7, the next bit is 1 1, so the last bit is 2 power 7 plus 2 power 6 2 power 7 is 128 plus 2 power 6 is 64, which gives us a value of 192. And since we just have two ones enabled, this is a slash 2 address mask. And the next, since we have 3 bits enabled, that gives us a value, decimal value of 224, and this is a slash 3 address mask. Similarly, as we start to turn on all these bits to 1 from left to right, eventually we get a value of 255 in the end when we sum them up together. And that is why we call them as a slash 8 prefix. So imagine that this is just the address mask for class A, as we had seen here. As we had seen here, this is a class A address mask. That is why, since it has 8 bits turned on, it is slash 8. And the class B, it has another extra 8 bits turned to 1. That is why it is slash 8 plus slash 8. That makes it slash 16. Similarly, for class C, it is slash 8 plus slash 8 plus slash 8. That makes it slash 24 as a decimal format. Sorry, slash 24 as its address mask. I hope all of you guys are with me now. So here, if you ask me, all of these are um, simple decimal formats. But what if we add? What if we write? What if we turn these zeros to 1? Right? These are all classful address masks, right? These are all classful address masks. I hope you guys know what is a classful address mask, meaning all these have a slash 8 classful address in class A, slash 16 is class B, slash 24 is classful mask for class C address. But the moment we use an IP address belonging to the range from 1 to 126, let's say that I write an IP address that is 10.10.10.10. Okay, so if it is a class full IP address, I can write the address mask as slash 8. But what if I write, the IP address as slash 12? Okay, meaning that I have 8 bits here, but then I also use another 4 bits from the second octet. But my first octet is of class A, but the address mask is not of class A. It also includes few bits from the second octet. And thus, instead of calling this IP address as a classful IP address, I start to call this IP address as a classless IP address. Right? Now, how do we define, or how does a computing device sees this classful or classless IP address? Let me tell you, the computing device is not bothered about this IP address value 10.10.10.10. It is not bothered about that value. All it cares about is this value that is after the slash. How many bits is 1, how many bits are 1? Based on that value, it calculates the network address. It also calculates the network bits. It calculates the subnet bits, and it also calculates the host bits. So here is an example of a classless address mask. So here, if you see here, this is 8 bits of 1. Here is another 8 bits of 1, and then I just have 2 bits. So I have 8 plus 8 plus 2. That makes it 18 bits, right? 18 bits of consecutive ones, right? So how do we write this in a decimal format? So this is 255, as we know. If we turn on all the bits to 255, if we turn on all the bits to 1, it is 255. The second octet is also 255, right? The third octet, since only the first two bits are on, that makes it 2 power 7 plus 2 power 6, right? That is 128 plus 64, which makes it 192, and hence this IP, the address mask of this, of the IP address that is being used here would be 255.255.192.0. Similarly, you can see all these binary forms converted to their decimal equivalent decimal format. So if you have any doubt, please do pause this video, look into this table, and try to understand the conversion of a binary mask to a decimal mask. You can rewind this video and try to understand the logic behind the network bits and the host bit, and also you can check out this table to understand the logic how any computing device finds the decimal equivalent and also finds the slash decimal number. Now, as we have understood the as we have understood how a computing device sees the IP address, let us understand it in our own language, because of course it is difficult for us to understand ones and zeros. So let us now get inside the subnetting math. Okay. Okay, so let us first take an IP address. Let us first take an IP address. For example, I take the IP address as 192.168.40.1. All right, now I give this an address mask of 255.0.0.0. Okay, so how will we find, usually in an interview question or in a CCNA exam, usually they ask this, right? Can you tell me the subnet ID, and can you tell me the broadcast address of this IP address that I have written here? So let's try to find that out. Let us try to find this solution using the subnetting math, easiest subnetting math. Okay, all you need to do is write down this IP address here, 192.168.40.1, along with this address mask 255.0.0.0. Okay, all you need to do is now wherever there is 255, 255, okay, just copy that particular octet here. Okay, that is 192, right? And the rest of this, the rest of this goes as 0.0.0. Okay, so this becomes your network ID. Okay, now they will also say what is the broadcast address for this. Okay, all you need to do is convert all these zero numbers, right? All these zero numbers to 255. So this would be 192.255.255.255. This becomes your broadcast ID or broadcast address. Okay, this was very simple with just one 255. Okay, let's take another example where instead of one single 255 we have multiple 255. For example, 255 dot 255.0. Now let us find out the network ID and the broadcast ID. So let me erase this. So 255.255.0. As I had said, copy the octet wherever there is 255. So this becomes as 192.168.40 dot, then this 0 becomes 0 here. So this becomes your network ID or subnet ID, right? And if you need to find out the broadcast address, all you need to do is convert this particular 0 to 255. This will become your broadcast ID or broadcast address, right? So this was very easy, right? This was very easy. So let us do few uh, questions here. Okay, let us do few questions here. So here there are few IP addresses given with their address mask. Let us try to find out their subnet ID and broadcast address. Okay, so the first is 10.77.55.3. So wherever there is 255, copy those octets. So that is 10.77.55.0. This becomes your subnet ID, right? Now, all you need to do is change this 0 to 255, and that becomes your broadcast address 55.255. Right? Similarly, let's try to solve this third one. Here, okay, not the third one because the octets numbers are same, octet values are same. Let's go to the last one. Here, just copy the value where there is 255. So it becomes 1 dot, rest of them becomes 0, 0 dot 0 dot 0. This is your subnet ID. The next, the next, the broadcast address will be 1 dot, change all these zeros to 255, 255 dot 255 dot 255. This is your broadcast address. So I would suggest to pause this video and try to do the calculation by your own, and you can resume the video once again for the solution. Here is the solution for the previous questions that we were seeing. So if we saw the first one, right, we saw 55.0 as the subnet ID and the broadcast address as 55.255, and the last one here, the subnet ID was 1.0.0.0. The broadcast address was 1.255.255.255. So finding the subnet ID and the broadcast address for easy masks. Easy masks meaning it's just 255. But in a subnet or in the octet, not every time you get to see all bits as one, because 255 means that we have 8 bits that are ones, right? What if what if few of these bits are zeros from the left, right? So those will be not 255 but some other value, right? So they can be 192, they can be 224 or 128, etc. What should we do then? How can we calculate the subnet ID and the broadcast address? Let us see how can we do that. So I will try to make this math as easy as possible. So here let me take the example of the first IP address, that is 10.77.55.3. and the IP address is 255.248.0.0. So 10.77.48.3, and the subnet mask that was written was 255.248.0.0. Okay, so the same calculation that we saw for an easy mask, right? We'll do the same kind of calculation. So wherever there is 255, copy that particular octet. So this becomes 10. Wherever there is 0, copy those octet as zeros, right? Now, we just have one octet left, which is 248. So let us use a magic number, and that magic number is 256. Now, why 256? Right? So we have values from 0 to 255 for the address masks. So including 0 till 255, there are 256 numbers, and that is why we use the magic number as 256. As simple as that. Okay. So now what are we going to do is we will use this magic number and subtract the number from the with the difficult mask here, that is 248. So 256 minus 248, this gives us a value of 8, right? Now all you need to do is go with the multiples of 8, go with the multiples of 8 till you reach till you reach a value that is closest to this third this second octet, because this difficult mask is for the second octet. So we will go with the multiple of 8 and up to a value that is nearer to 77. So let us write that down. That is 0, then 8, multiples of 8, 16, 24, 32, 40, and 80, right? So these are the multiples of 8. So we reached a value, right? We reached two digits, or we reached a value 80 that was closest to 77, and then you should stop. So this 77 comes in between 72 and 80. So we will take the value, we will take the digit that is lower than this particular octet's value. So 72 is lesser than 77. So write that down here, 72. This becomes your subnet ID, not the network ID. This becomes your subnet ID. So here, if you see that with this particular address mask 255.248.0.0, we get many subnets. Okay, we get many subnets starting from 0, okay, 0 till 8, then 8, 16, 24. So it usually is like this, from 0 till 7. So you have 0, 1, 2, 3, 4, 5, 6, 7 as different subnet numbers. Different subnet numbers. Okay, different subnet numbers. Then, meaning that the IP address bit in this subnet range would be 10 dot 10 dot 1 dot 0 dot 0. Okay, then it will go from 10.1.0.0 till 10.1.1.255.255. Then the next subnet range would be 10.2.0.0, and it will go up to 2.255.255. Similarly, this subnet value would change or would go from 1 to 7, because this 8 is the subnet id for the subnet range from 8 to 15, right? Similarly, the IP address range from 8 to 15 would be, I'm giving you an example, that 10.8.0.0, then it would range from 10.8.255. The next IP address would be 10.9.0.0, and it would go up to 10.9.255.255. Similarly, this would go up to 15.0.0, and the broadcast address would be 15.255.255. So our IP address here 10.77.48.3 is in the subnet range of 72.0.0, which would go up to 10.79.255.255. This becomes our broadcast address. This becomes our broadcast address. Okay. I hope this was clear. If not, please rewind the video and you will understand the logic behind it. Okay. So let's not worry about this. We will understand this with some other example as well. Let's take the example of the second IP address here. Okay, so that is 172.30.99.4. So what we will do is that wherever there is 255, we will copy that particular octet number as such. So that gives us 172.30 dot. Now we have 192 for the third octet, which is a difficult mask. So what are we going to do? We are going to subtract. We are going to subtract this 192 using our magic number, right? So 172.30 is what we have found till now. So we need to find what would be the subnet ID for this. Now subnet ID is found using the magic number, that is 256 minus 192, right? Because this is the difficult mask, we get a value of 64. Then using 64 as the multiple, we will get 0 as the first value, then 64 as the next value, then we would get 128. So our third octet value, that is 99, is between 64 and 128. So the lowest of these two values is 64. That becomes our subnet ID. 64.0 becomes our subnet ID. So with this uh, subnet mask or address mask, you get different ranges of subnet. In our previous example, we saw using a multiple of 8, we got different subnet ranges. Similarly, here we have different subnet ranges, and all these subnet ranges will have hosts per these subnets. So we have subnet range, right? And these subnet range will have hosts. So these hosts are per subnet range, per subnet range. right? So this is how you usually calculate the number of hosts in all these range. So here in this example, this 64 is the lowest between 64 and 128, and hence it becomes our subnet ID. Now, what would be the broadcast address for this subnet range? The broadcast address of this subnet range would be one less value from this 128. So that would be 172.30 dot what is 128 minus 1, that is 127, and convert this 0 to 255, and this is our subnet ID ranges for this particular address mask and IP address, right? If you're here with me, let's calculate another one. I hope the math is easier and understandable. Okay, let's calculate for the fourth one. So we have 10.77.3.14 and the address is 255. So write down the first octet 10, the next octet is also 255. So write down the next octet, that is 77. Then we have two more octets, but the third octet is 128 and that is our difficult mask. So 256 minus 128. So what is 256 minus 128? That gives us a value, I'm sorry, that gives us a value 128, right? If we subtract 256 minus 128 gives us a value of 128. So what we need to do is that we have to go on the multiples of 128. So that gives us 0, 128, right? We reached that value 0. So and 128. Now this octet, right? This number in the third octet is between 0 and 128. So the lowest of these is 0. The subnet ID hence would become 0.0, and the broadcast for this would be 128 minus 1, right? And write that down in the third octet. So 10.77.127 dot convert the last octet to 255. That gives us the broadcast address. So I hope this math was very easy to understand and calculate the subnet ID and subnet ID and broadcast address. All you need to do is use the magic number 256 and calculate the multiples of the remainder that is seen here. So I would repeat the steps once again. The first step is to copy octets which have 255 as their address mask, right? Second, what you need to do is use the magic number 256 minus the difficult mask. I call it a difficult mask, right? Now what you need to do is third, the remainder of this second step, right? You use the multiples, you use the multiples of the remainder and find out the number, right? Here in these examples we saw 77, 99 and 3. You need to find out between which multiples do these difficult octet numbers fall, right? Then the fourth step is to use the smallest in that smallest value in that range as your subnet ID, and your broadcast would be one less than the largest value in that subnet range. One less than the largest value in the subnet range. That gives you the broadcast address. Okay. So I hope this was easy, and uh, please pause this video, right? So you can see the IP addresses, their mask, and their subnet ID given here. Similarly, for the same IP address, you can see the broadcast address. You can pause, you can practice using my method of using the magic number, copying the um, 255 octets as such, then use the magic number, then use the multiples, find the range. The lowest value in the range becomes a subnet ID, and the broadcast address is one less than the highest value in that subnet range. I hope this math is easier once you start to get a hang of it. Once you start to calculate using this method, this subnetting is a piece of cake. I hope this video was very informational. Please like, share, and subscribe to the video, to the channel. I'm sorry. And if you have any questions or any questions that you saw on internet and would like me to solve, please do let me know. I would create a video on it later. Thank you and have a great day.